Hi, these are going to be notes for you on the ellipse. So an ellipse is basically an oval, and it's got a bunch of characteristics that I'm going to try to explain to you. This is the general formula for an ellipse where x and y are both squared. So that's different than a parabola. In a parabola, either only x is squared. In a parabola, if x is squared, the parabola opens up or down, or only y is squared. And if y is squared, then the parabola opens left and right. But for an ellipse, x and y are both squared. You will have to take the formula of an ellipse that looks like this, and by completing the square and things like that, you're going to get it into one of these two forms. So one of the forms is where your x term is squared, and the bigger number in the denominator is under the x squared term. If you have a situation like this, where the bigger number is under the x squared term, your ellipse is going to be an oval who's longer in the x direction and shorter in the y direction. So it'll be longer than it is tall. If, when you get your equation into the format for an ellipse, if the bigger number in the denominator is under the y squared term, then the ellipse is taller than it is wide. So it would be an oval that's a taller oval and not quite as wide. You're going to need to find the value of c, because that will help you to find where your foci. There's more than one focus, so it's foci in the ellipse. And to find c, it's the square root of a squared minus b squared. And e is the eccentricity, so that's a new formula. The eccentricity of an ellipse tells you whether it looks more like a circle or more like an oval. And the closer the number is to 0, the more the ellipse looks like a circle. And the closer it is to 1, the more it looks like an oval. So I'm going to just show you how to draw an ellipse that looks like this, where your bigger number in the denominator is under your x term. So the x squared, the x direction is going to be your longer axis. So you still look at your HK, and that would be your center. So the center of your ellipse has coordinates HK. Because the bigger number is under the x squared term for this ellipse, this is going to be your longer diagonal or your longer vertex of the ellipse. So you would take the square root of a squared, which is a, and because, again, the bigger one's under the x, you would go a units to the right and a units to the left of the center. So this is the distance of a units. This is the distance of a units. Then you take the square root of the b squared, and those would be called your covertices. These 2 points are your vertices. There's 2 vertexes in an ellipse. You take the square root of the b squared, that's going to be your shorter diagonal. Those are called your covertices, and you would go down b units and up b units. So this has a distance of b units. And then the way you draw your ellipse is you just draw an oval shape. These are the 4 points that you would have to hit. And the ellipse would look like this. Now, the foci, there's 2 again, 2 focuses, 2 foci, are always on the longer diagonal. So an ellipse that looks like this, that's longer in the x direction than the y direction, your foci are going to be points on your longer diagonal. And the way you find the foci, you start at the center, and you would go c units to the right, that would be one focus, and c units to the left, and that would be the other focus. So I think that what we're going to do is just try an example, and hopefully that'll help you to understand this. So the first example in your notes is x minus 2 squared over 16 plus y plus 1 squared over 9 equals 1. So this is in the right format to start to graph the ellipse. So you've got to look at the denominators and see where the bigger number is in the denominator. The bigger number, the 16, is under the x squared term, so that means this is going to be an ellipse that's longer in the x direction than in the y direction. You have to find your center of your ellipse first, and your center is just HK, so the center is 2, -1. And then the A direction is going to be the square root of the bigger number. It's going to be the square root of 16, so it'll be 4. And the B direction, in this case, it'll be the Y direction, is the square root of 9, and that'll be 3. So the way you would graph this ellipse is you would start at the center, which would be positive 2, negative 1. There's your center. It's longer in the X direction, so you would go 4 units left and right in the X direction. So 1, 2, 3, 4 units to the left, 1, 2, 3, 4 units to the right. Those are your vertices. So the coordinates of the vertices for this ellipse, what you should do is you should start with the center. You should go left and right for your A units to find your vertices, and then just read those coordinates off of the graph paper. The one over here will be negative 2, negative 1, and the other vertex on the other end of the longer diagonal, when we started at the center and went 4 units to right, the coordinates of that are 6, negative 1. Then, from the center again, you would go up and down your B length. So you would go up 1, 2, 3. This would be called a covertex. You would go down 1, 2, 3. That would be a covertex. And again, do this on graph paper. Count where your boxes are and look for the coordinates. So one of the co-vertices has coordinates of 2, negative 4. And the other co-vertex would have coordinates of 2, 2. That's all the information you need to graph your ellipse. Then you just, as best you can, make it into an oval shape. Whoops, I made a mistake there. I need to make it into an oval shape. This is much better on graph paper. Of course, label it with the original equation. Now, to find the foci, you have to find the value of C. So in an ellipse, C is equal to the square root of A squared minus B squared. In this case, C is equal to the square root of A squared is 16 and B squared is 9. So 16 minus 9. So the center of, or the value of C to find your foci would be the square root of 16 minus 9 is 7. It would be the square root of 7. So the coordinates of the vertices, or of the foci, you would start at the center of the ellipse. The longer diagonal is in the X direction. You would go C units to the right and C units to the left, and those would be the coordinates of your foci. So for this ellipse, the foci would have coordinates. The X value of your vertex is 2, and you would add and subtract the square root of 7 from that, and then the Y value of your center is negative 1. So those would be the coordinates of the two foci. And then the eccentricity of this ellipse, which is how circular or how oval it is equal to C over A. The eccentricity of this ellipse, C is the square root of 7 over A, which is the square root of the bigger denominator. So it would be